Hi there, my name's Mike. I'm a senior software engineer at Gretel, and in this video I'm going to be walking through our new Python library called Benchmark. Benchmark is a tool for comparing the performance of different synthetic data models against different data sets. So it's available in our open source Gretel trainer package, so just pip install Gretel trainer and you'll be on your way. This is start things off by just importing the module. And to think about benchmark, there's basically two sort of halves to benchmark. There's data sets and there's models. So we're going to start with data sets here. You can make data sets from your own data. This is a local file on my laptop. I just use this make dataset function to turn it into a data structure that benchmark understands. You have to specify the data type of your data set. This is an enum, so you can either provide the string value or you can use one of these enum constants here. Gretel has also curated a collection of data sets that you could use if you don't want to use your own. So we've got a couple functions here that'll help list a bunch of data sets that we have available in S3. List Gretel datasets just out of the box will list all of the options, but you can also filter based on either data type. These are the same values as above, so let's filter down to time series data. Okay, there's 3 of them. Or you can provide tags, and you can even mix and match. So this is going to focus all the way down to just one data set. The tags are, you can use this function to just list all the tags available. Just helpful for browsing through the curated data sets. If you know the exact name of one, you can grab it by name. I'm going to do that here. We'll use this iris data set from Gretel and the demo data from my local laptop in our comparison later. That's all there is for data sets. We're going to move on to models now. So on models, the easiest thing to do is use the Gretel defaults. These are pre-configured based on our public blueprints, which are also open source on GitHub. So you can import all these model options here, and we'll see how we pass those down to our comparison function later. You can also customize Gretel models. So if you have your own config file that you've run on Gretel Cloud that maybe tweaks the parameters of our LSTM model or CTGAN or any of our other models, all you have to do is import the Gretel model class, make a subclass of it, and just specify this config property. This can be a path to a YAML file or a JSON file with your config, or you can pass the config just as a Python dictionary right in line. And then lastly, you can make your own synthetic model implementation that doesn't have anything to do with Gretel at all. All you have to do is define a class that has 2 methods on it, train and generate. Train is going to take in a data source as a string and do whatever you want with it. Clearly, right here, we're not doing anything particularly fancy with it. And then generate is producing a data frame of synthetic data. Like I said, in this case, not anything interesting, but you've got the whole universe of Python available to you. As long as your dependencies are installed and available wherever you're running benchmark, we can run whatever you want in your custom implementation. So we talked about data sets, we talked about models. Let's put them together into a comparison. This is sort of the main function of benchmark, is this compare. You give it a list of data sets and a list of models. Here I'm going to just use 2 of our pre-configured Gretel models and just launch this setting to this value comparison. So this is going to spit out a bunch of log information. Under the hood, we're using either our Python SDK or the rest of the Gretel trainer project that benchmark lives inside. And we're going to use these to basically submit this work to Gretel Cloud and wait for results. So we've got a bunch of log output here, just telling us what's going on. What's really cool is this is running in background threads. So I can call comparison right now and see, okay, Amplify, one of our fastest models, is actually already finished training in just 24 seconds on this pretty small data set. The other three are in progress right now in the training phase. This results output, this is a data frame. We've got basic info about the data set that you used, the model, and then this is sort of on the right, our results area. You can see we'll have the train time, the generate time, total is just summing the two together, and then SQS, which is our measurement of the quality of the synthetic data generated. We can refresh this as much as we want. Looks like starting data generation on 303. So one of these is probably now in the generate phase. Yep, there we go. And yeah, we can just kind of click this a bunch of times as much as we want, or if you just want to wait for the results to finish, we can call this wait function. This will block until all four, in this case, all four jobs reach a terminal state. And then you can export the results to a CSV and view it in your favorite spreadsheet program of choice. Plenty more information are available on our docs. And yeah, we look forward to you using Benchmark. Thanks.